Hey everybody, this is Larry. This is me going with Q4 of the weekly contest for 15 minimum number of valid strings to form target 2. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So this one, first of all, this is Q4. This is a repeat of Q3 but with a higher constraint. I'm not going to go over everything that we went over in Q3. I know there's some homework that I also assigned there for you to learn, like Z function and stuff. And honestly, this one, I think, in a way, the Q4, I probably just cheated. So yeah, so definitely hit the order button. But also, if you're trying to, so what I'm saying is that Q3, at least the video and all the things you need to know on it, is a prerequisite for Q4. Hopefully that makes sense. So I'm not going to repeat them. So definitely check that video out. Okay, so we're not going to go over the Z function, but actually, let me bring up Q3 real quickly first, right? So this is my Q3 for y'all. I actually don't think I mean, I should have highlighted a little bit better, at least the Z function stuff. But yeah, so yeah, there's the Z function. I went over. I didn't go over it in video, but yeah, but this is how we use it. We have this thing and this thing, right? So what are we doing here? Let me bring up the thing, right? Oops. This is from the Q3 video that we haven't updated yet. But the this is the visualization, right? The thing that we're doing with this problem is that for each I, what are we doing? For each I, we're updating. Let's actually add connotate. Yeah, for each I, we update I plus 1 to I plus x, where x is the edge, the length of the edge. Again, that's in the video. To dpi plus 1, or whatever the minimum is, right? Because there could be a smaller number hitting that, right? But I don't think that's possible. I think it's always monotonic, so it should be okay. But yeah, so that's basically the thing, right? And as I say, I am only going to explain my solution, and we'll talk about afterwards. There are some other apparently similar problems that we can take a look at. But yeah, so for this one, we update I plus 1, and this is the part where I said I cheated a little bit. Is that so? Looking at this, I immediately knew that this was a segment tree problem, and what I mean by that is just that, yeah, because what are we doing, right? We update. We have an update thing. And we have a query thing. Query thing is, I guess, just getting whatever the value is for, right? So that's basically what I end up doing here. I'm not going to show the segment tree code for a second. And this code is really ugly because this is segment tree. But I just want you to kind of focus on the structure, right? So here, when we are up to I, we update the query for the segment tree. By looking at the ith index, when we're ready, and then and then we set x is equal to the size of the edge, and this x is the same as this x, where it goes from 1 to e sub I. So e sub I is the biggest thing. So then now, if x is greater than 0, because if it's 0, it doesn't do anything, we update the range from I plus 1 to I plus x. The same thing we have here, updating from I plus 1 to I plus x to dp sub I plus 1, which is what we do here. And that's pretty much it. If you're familiar with segment tree and if you have a template ready, that's all you need to do, really, right? I mean, we will go over it a little bit more detail, but honestly, I didn't do it that much. I did not care about it during the contest, so that's pretty much the idea. I mean, you can kind of see, right? This is a segment tree. I kind of do a build, but this build is just setting everything to infinity except for 0, which is the 0 element, right? As the base case. Everything else is the same, right? So you can kind of, I mean, I guess I added this comment, but you can see that, the code is very similar. Sorry, I'm giving you a headache. The only thing is that I added the segment tree, and we have a query and a range, and that's pretty much it. So why is this fast enough? Because now the complexity on the old one is n squared, because this is O of n. This loop can go up to n. For this one, we have an O of n loop. This is log n. This is log n. So then this becomes n log n, and we are much happier. Yeah, because everything else is the same, really. So yeah. So just as a little bit of, so that's pretty much all I have for this one, really, for the structure. It's kind of, like I said, it feels very cheaty. It is what it is. But we'll go over what segment tree I use, right? So, excuse me. So the segment tree I use, not gonna lie, I did it from ChatGPT. And yeah, basically I just got the version where we have an update range and a query range. That's basically it, and we don't even need a query range. I think we could do a point query, though I didn't ask ChatGPT for that one. But yeah, and this one happens to have lazy propagation and lazy update, and that's pretty much it. I mean, you can look at this code, but let me show you the top. I don't know that this is interesting. You can definitely probably even get it cleaner, and if you want to see the Z function, but yeah, I mean, that's all I have for this one for how I did it, right? So so yeah, so one thing that I want to point out an example code for is, let me see if I could find it real quickly. Someone on my Discord mentioned it. Okay, so let me show you this code real quick, just to go over it. Let me open a new window. This is from what is this handle? RJM whatever. So this is his code, and the idea here is that it is very similar to apparently the Jumpman problem, which kind of makes sense, but I just didn't think about it. But the idea here is that, okay, the Z function is the same. Could use more spacing, but it is mostly the same, right? So you can see this is very similar to my code. I'm sure this is the same, more or less. I'm not gonna look at it, right? And then it's just this part that's different, which is that yeah, here we have a monotonic, we have a mono queue, right? Where whenever you have an update, so you want to update over a range, and because that length will always kind of like, shrink one by one, but also when you get a new one, it goes farther, right? So then it goes to the index, and depending on how far you can go. So I think during the contest I was thinking about along these lines, but I also honestly didn't think that much along these lines, because oops, I guess I don't need to do it. I didn't think that much along these lines because I already have a solution, right? So that's why. But the idea here is that, let's say you have this, right? Then now you can think about these as segments as well. Let me change the color real quick. And how this works is that, now, oops, now you have this, right? So then now as you go from this point to this point, you know that you can get here. And then now if you have another one, let's say, this one goes all the way here, then now you have another segment almost, right? You could say this segment. But the thing is that, and then, you go left to right. But the thing is that we know that here, this is 0, or this is 1 cost, right? So every time you see a new segment, it adds 1 cost to it, right? So that's really the idea behind this one, is that, yeah, that's basically the idea, is that every time you have a new segment, it adds 1 cost when you see the end of a segment. So you always want to, in a kind of greedy way, you always want to do the longest as you can from the beginning, and in this way you could keep track of it using monoq, because when you remove these, then these goes away, and then you kind of now reduce to this thing, and then maybe try to remove them as add them on as much as possible. In this case, you'll choose greedy, which is this is the farther one, and so forth, right? You choose the farthest one that you still have on the queue. So that's pretty much the idea for this one. And here's the code. I don't know if it's that clean. It's it's not Larry approved, or I don't know if it is. It's just not Larry written. But yeah, so you can see that we set up a queue. If there's a jump thing, we just kind of and then we keep on popping things from the back, because we know that this goes farther, then you don't need the things from the back, so you can kind of add that way, and then you could add stuff to the beginning. Yeah, I think with the visualization, this code makes a lot more sense. I think I missed the thing about popping from the end though. Let me bring up the popping from the end. So popping from the end is something like this, where when you see this one, when you push this one, you're like, oh, this totally dominates this other one. So then you just pop them from the back, and then now your queue just looks like this with this kind of overlap. So that's really basically the idea for this monoq version. Definitely much cleaner, and at the very least, it's the code is much faster, I would imagine, or at least complexity-wise, right? Because this is still the old same thing as here, which I took out it. Yeah, this thing is going to be the same as this thing, but then now this is O of n, and yeah, and because each index here can append or queue, can only append once, and so each one can only pop once. So this is all the queue stuff is amortized O of 1. So this is O of n in total, which is obviously much faster. So yeah. Also, if this exact code doesn't work, I take no responsibility, because it's not my code. I'm not gonna run it. But yeah, that's all I have for this one. That's the idea behind monoqs and stuff like this. But yeah, there's also another. I solved it another way. If you kind of look at the leaderboard, I actually did it in Java because I thought Python may be a little bit too slow, so I kind of worried about it. But I actually did it backwards, which I think end up being okay, because I'm not. I wasn't able to prove it, and you could kind of, if you watch the live portion, I actually go beyond the end of the contest because I wasn't able to prove it until I realized about this monoq thing, and I'm like, oh wait, I think I accidentally did this, so it is actually correct, but I'm not gonna go over that solution. But yeah, anyway, that's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you could watch me. Let me end on my code. Oh no, well, on my code. That's all I have for this one. Let me know what you think. Thanks for watching. And you could watch me solve it live during the contest now. Maybe it is. YOLO. I hate Leetcode. How am I doing? Yawn shine. I mean, I'm not surprised. People got Q4 as well. How many people got Q4? 12? Doing okay. Good. Okay, so what is the Q4? Let's copy this for here for now. So I want to keep this for a second. Oh, actually, I guess I would do this in Q3 time. Yeah. Okay, so we have benchmark of 60. We want to keep it to right? Is that the only difference? And that will time out because of this thing. This thing I think is fine, but okay, let's go back to Python, and then we'll have to convert it back if we need to. Okay, so the idea is just this function, right? So it's pretty straightforward, honestly. I thought about it, but it's just that Leetcode is being silly. Or maybe I could still do it in Python. Okay, so yeah, so then now we want actually y plus x is equal to max of y plus, because that's how far we have to go back, right? So then now instead of doing this, we go from 1 to n plus 1, And then now we go with, well, we don't do that anymore, but yeah, so for x is equal to this number, then we have this thing, right? I minus x. Is this right at least? No. How did that didn't go out of bounds before? No, this shouldn't go out of bounds. Index. This shouldn't go out of bounds. Why is this going out of bounds? Am I off by 1? Maybe I'm just off by 1. This should also not go out of bounds. What is going on here? Oh yeah, 1, 3. So then that's making from 4. Yeah, I plus. Oh, I need the edges to go to n plus 1. Okay. Okay, I'm wrong here. I just kind of didn't realize. Yeah, okay. Stop explaining, Larry. It's fine. You got it. Okay, so this is now right. Okay, I'm converting it to Java so I could test that this is still correct. What changes did I make again? Where's my window? Okay. What changes did I make again? I have to save this thing. Oh yeah. I think this is it though. Just nice. Nope. What else did I change? Okay, that was it. Wow, that's actually surprising. Okay, let me also do this just to make sure that it runs fast enough. Oh, this is make sure that this doesn't run fast enough, I suppose. So this should be good, right? Okay, so then now I can do this function, which is just yeah, just a sig tree thing, right? I mean, I'm sure a lot of people have gotten it already, honestly. Oh, that's surprising. I mean, this is pretty straightforward, right? Yeah, okay. Yeah, let me ask ChatGPT for a sig trees. Sig tree with in Python. So this time. Okay, right. I don't know, I didn't wait for it to finish. Okay. Okay, so sec3 is equal to I'm looking at the tree. 3 infinity times n plus 1, right? And now dp, so x is equal to e sub I, right? So then now we want to get from okay, s3 dot update 0 0. Then we want to go from xt dot query I minus x, oops, I minus x, I minus 1, dp sub I is equal to this, st update I dp sub I, and we should be good. In theory. Never any easy, is it? Oh, we don't want min. I think what do I want? Oh no, it is min, but plus 1. Right? Okay. Is this gonna be fast enough, Larry? Let's try. I don't know why I keep on having to type this. Was it 5,000? Need to be better about generating these. Okay, this is fast enough-ish for 5,000. It's actually a little bit too slow even for 5,000, but 50,000 is not even going to run because this is Python and Leetcode hates Python. So let's convert this to Java. Where is that window? Convert this to Java, please. This took 12 seconds for 3 max cases, which is not great, but hopefully the segment tree version is going to be better. Okay, I'm going to keep. I'm going to keep this, and also I want to test the end case thing. It's still printing. Where did I have that? Did I have it here? I guess I should have kept it there. Wait, I should have kept that. And while ChatGPT is still giving me code very slowly. Oh no, there it is. I was going to try to. This was actually pretty easy, but I don't know. It is what it is. Ooh, oh yeah, I have to make the same changes every time. And then now we want I thought I had this, but I guess I never submitted it, so. Oh, the summation is less than 10 to the 5th, so actually maybe I don't need to do what I'm doing. Maybe I actually over. Okay, fine. YOLO, let's go. Yeah, okay. Oh, wait. That's our Q3, Larry. Submitted for the right problem. Okay, that's good that it works for Q4 though. Okay, Q3 I mean. Alright, Q4. That would be very funny if I just walked away and like, whoops, I didn't need this after all. But yeah. I mean, I knew how to do this the entire way, honestly. I know that I took a long time between 3 and 4. And I think this is where more practice would have came in handy. Just because I knew that I knew how to do every step of the way. Everything was implementation, which is kind of sad that it took me 28 minutes to implement it out. But as soon as I write this for loop, I mean not here, but as soon as I wrote the for loop, I knew that as soon as I wrote that photo, I knew how to optimize it, but I just want to make sure that I get the dumb one right first. I wonder if segment tree will be fast enough in Python. Why is that? This is Q3, right? Apparently the Python one is wrong for some reason. Maybe infinity is like weird wrong, yeah. Oh, because why is this 1? Oh, this is the target. Whoops. But this, yeah, why is this 1? No, this is, well, I mean, my understanding is of it is right. I don't know why this works in Java and not this, but I'm glad that, you know, it worked anyway. But E is 0 of 1, and then do I just have not indexing? No, this is right. We update this, so it should be correct. Is the segment tree wrong? Maybe the segment tree is wrong for this one, because maybe this infinity, it doesn't gel with the infinity that I pass in, which is possible. Because that's why we have this weird infinity, maybe. But yeah, I don't know why this is giving me infinity. So maybe their segment tree is wrong for Python or something. Or it just never built correctly? I don't know. That's actually really surprising. I'm so glad that but yeah, I mean, I don't know why. I would be very frustrated during the contest. I mean, I already kind of am. I don't even remember how I got the wrong answer anymore. I am going to try to upsolve, or at least try to figure out why this is wrong for Python. I mean, I kind of use this as a black box, so it should be right. But I don't know, honestly. I don't know why this is wrong. The Y is right. Yeah, I remember checking that, right? And the n square one. And oh yeah, the wrong answer is because Python times out and we have to convert to Java, right? That was the thing, which is kind of, oh, that's weird. Like, why is it just returning infinity for all the previous things? No, but DP does, some stuff does work. So it's returning 3, 2. So why is this returning -1? Did I just not? Am I, like, is my indexing wrong somewhere? I don't get it. So it goes to 1. What is n? N is 1. So this goes to 1. This goes, so yeah, this should loop. I'm so confused why this is wrong, actually. Yeah, this is right. 0. We update it. Oh, this is for some, maybe the template is wrong because this is closed for some reason. That is funny. And in a weird, well, it didn't affect the test inputs, which is actually really funny, but also, like, the Java is different from this, which is wild. I mean, it made, oh, so there you go. But it's wild because the Java segment tree is closed, or yeah, it's closed, while the Python segment tree is opened. That is wild. I mean, yeah, I was about to curse Leetcode just because I'm so used to it. But wow, that was actually not Leetcode's fault. That was whatchamacallit. I'm just curious whether Python would have been accepted using the faster query tree. Okay. So if I had done, I guess if I had done the optimization to begin, it would have worked for both of them. But the n square one doesn't seem to work for Q3, which is actually sad, right? Is that what happened? Oh no, I got a wrong answer. Oh no, yeah. What was my first wrong answer again? Oh no. Oh yeah. I got the wrong answer because I knew why I got the wrong answer. Maybe I'm wrong on this one though. I got the wrong answer because I didn't do the for loop. So yeah, what did I have this? Oh, I converted to Python or to Java. Do I have to Python code? Maybe I'm wrong. Maybe I forgot about that wrong answer, so that was my fault. Maybe I just thought 5,000 because I created the test case, but it was wrong. Because the test case was too harsh. The reason why the test case was too harsh is that I forgot about this constraint, the sum of the input constraint. So is this the 3? So okay, so maybe I'm wrong on what or everything I said. So okay, so this is the dumber one that I had initially. Yeah, with the range. So let's give a submit. Yeah, maybe it still times out because I don't know. Okay, if it times out now, I still blame Leetcode. Oh, so okay, so that wasn't Leetcode's fault. That was my fault. But I definitely took my time, just even though I knew how to do it immediately, honestly. But I just wanted to be careful, maybe too careful. Who knows? But yeah, I mean, I think this is also just what practice will buy you, right? Because I don't know if how much faster I would have gotten it, but I probably would have gotten it much faster. Like on self, this is actually pretty straightforward. I did have one minor misunderstanding, which I got a wrong answer from, which is a legit wrong answer. I do not blame Leetcode for it. I just created a test case that was more intense than their test case. But I wanted to convert to Java just in case. But I would be so sad to get a wrong answer on it, though. To get this wrong answer, because of the segment tree difference. But yeah. All right. I mean, that's all I have for this one. Let me know what you think. Yeah. Thanks for watching Top 50, which hopefully redeems myself a little bit. I'm surprised that. Yeah, I mean, I'm surprised the time's on higher, to be honest, or like faster is what I mean. I guess this is pretty fast. I think I'm just too slow. Yeah, honestly. Yeah, it's because I don't know. Because I could have easily seen myself finishing like 10 minutes faster. Honest. I mean, without a penalty, you know, it's up to you. But yeah, I don't know. I did okay. I hate this new color leaderboard. I'm not a big or like it's fine, but I'm not a dark mode guy, right? So I don't know. I couldn't like this is on light mode. So yeah, I'm not a dark mode guy. Sorry, friends. But yeah, can I hack this? I'm just curious. Like, is this gonna leak information? Maybe I will. Okay. Anyway, thanks for watching. That's all I have for this one. Let me know what you think about these problems. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye. So yeah, I'm back. In case you're wondering, a bonus recording. I'm not quite convinced that my code works, so I'm just kind of looking at it again. Basically, the thing that I changed is well, that's just in So I had something that I converted it, right, to something like, okay. To look back, right? So then now it is. So I had something like this, right? Maybe not this because this is wrong, but well, this will never be happening anymore. That's why. I'm not convinced that. Okay, well, I had it right because this is the thing that we did. I thought so anyway, but. Okay, so this is. I'm not convinced about this one. In my mind, it made sense because I assumed it's symmetric, but maybe I'm wrong. I don't think that I'm right on this, or at least like I don't have a proof. It may be that they give the same answer, but so I'm kind of double checking real quick. Like this AI, okay. Like what if I just have yeah, this doesn't make sense as a DP array. I mean the solution is right, and I think I'm proving by AC almost, but so luckily I submitted the other solution. But this reduction doesn't make sense because this is giving me the wrong answer for this. Right? Well, like this is not the same answer as the other one. I think I'm trying to rewrite this using a new segment tree that allows me to update a range. I don't know if this gives me actually the update that I want, but I think this is right anyway. Okay, so then now, yeah, I think I just was wrong on the wrong seg tree. I mean, yeah, I mean, I think that should be fine. It's just a harder seg tree, but I'm checking the bounds on this one now. But yeah, so then now, I mean, we still have the same thing. I guess we can just do TP. Actually, that would probably work. And then, yeah, I think this is wrong. So what we want is actually year of index, right? And then this is this plus x. So we want to update No, not +1. So we want to update range of what is this start node thing? I always forget how to use it. Oh, 0 and then -1. So we want to update from this is I plus X, right? So we want to update from I plus 1 to +1 to I plus X plus 1, and we want to update it to dp sub I plus 1 if it's min, right? And then we said dp sub I is equal to st query range or whatever of this goes only up to n, goes from 0 to n now, I think. How did I have this again? Wrong answer one's fine. It's just, oh no, I had a for loop one. I think it's the last one maybe. Okay, so then so we want to update from so we want to query range I and I 0 n, and that should be good maybe. What is this? Line 5. Oh, it's just given n. Why do I get like random funky trees sometimes? Like the templates are always some weird thing. Why am I getting this syntax always on? Oh well. I think I'm always like doing off by ones on these things. update range. There's no X, is there? I think there's more, right? One, two. Oh, the value is. Well, looks cleaner. Maybe. Is this right though? I don't know. That's YOLO. This is Q. Let's do Q4 again, just in case. If it times out, I'll also be sad. But yeah, I don't know. I don't know which one is right. I don't know that. I think I just kind of messed up. I probably should have done that one first, to be honest. But maybe I should have done it this way. I don't know. I mean, this way is definitely more correct, but I cannot prove the other way wrong. Like, I don't know that I have the other input. And that's what I'm kind of spending time on, but I'm still trying to test it in some input cases for the old one. Yeah. Because this scares me. This should not have this, but I don't know how to come up with a counter case. It may be that Leetcode's counter cases are bad, honestly. Like, because I think this kind of merges, so maybe you get away with having it be 2. But the intermediate cases are really wrong, right? Like, this should be a 1, this should be a 1, something like this. Like, maybe I can do something like, I don't know if this is right, but and this is still 2, but I mean, this 2 kind of sees this 1. I don't know if I could prove this wrong, but it just feels wrong, honestly. Because the intermediate things are just very wrong, and right after I stopped recording and I went to the bathroom, I was like, that doesn't make sense on a second thought. That's why I'm kind of doing this bonus video. It's kind of sad because I still know how to do it. It's just that I was like, it's still mostly the same. But it's also like not an interesting problem because it's just a sec tree problem, data structure problem. So this is right because there's some like weird overlap, but I feel like this comes out of like it being greedy and not intentionally like I think it's just an accident more than anything really, but I don't know how to prove it right. Or prove it wrong rather. What happens if you have two disjoint things? Like this is like maybe there's some like weird greedy thing that it's working for, but honestly I don't know how to prove this right, or prove it well, or find a counter example, prove it well. Because this is a case that comes up if two strings overlap, right? Otherwise, if no string overlap, you only have one choice, so you always take that choice. If two string overlap, if two strings overlap, then it doesn't matter how you divide it, so maybe that kind of works, but that's just a lucky thing more than I'm not really convinced, to be honest. Wait, they say that the live leaderboard is capped at 200? Oh, it is, huh? That's wild. Was that the performance issue? That's funny. Right, someone in my Discord pointed out. Yeah, I mean, I'm gonna give it. I don't know. I mean, I guess I solved it the other way, but the correct way for sure. But I don't know. Like, if they overlap, and if you have a three string overlap, it also doesn't matter. So maybe it just works because I got lucky. But like on case analysis, I can't come up with one. Otherwise, I would have already, because it just kind of. Because if you connect two strings in any way, it doesn't matter which way you go. Like how you split the thing, is still, the cost is still 2. So basically it just comes down to like some segment thing. Okay, I think maybe my solution was right. But honestly, I don't know, and I'm not confident about it. I'm only going to talk about the. I'm only going to explain the correct one, so I guess it doesn't matter. But and maybe the other one's also right, but honestly, not super convinced. But overall, maybe I did okay, but it's not clear because maybe we'll fail in system testing. Yeah, thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, these problems, this explanation, everything in between. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.